The last section of Chapter A is a review on simplifying expressions involving fractions, as well as rationalizing fractions that may contain radicals or roots. This section is again marked with an asterisk because these skills will be important for us when determining limits in Chapter 1 and when simplifying what are called derivatives in Chapters 2 and 3 to make them more manageable to work with. In this section, we will review simplifying expressions with fractions by discussing operations with fractions, when it is okay to cancel in a fraction, and then working through some examples. We will also review simplifying expressions with radicals by using rationalization techniques, and then work through examples involving rationalization. First, we will review basic operations with fractions. These rules are true if we have numbers in our fractions, variables in our fractions, or even a mixture of numbers and variables. The first operation is how to add two or maybe more fractions together. We must get a common denominator in order to do this. One way to do this is to multiply the denominators together, although this is sometimes not the least common denominator possible, as there may be factors in common already. We will see examples of this in a bit. We can change the denominator of a fraction by multiplying it by something, as long as we multiply the numerator by that same something. So we can't change the denominator or numerator of a fraction by adding or subtracting the same thing in top and bottom, only by multiplying by the same thing in the top and in the bottom. So a over b here can be multiplied by d in the denominator, as long as we also multiply by d in the numerator. The reason why we can do this is because d over d, or anything over itself, this is just equal to 1. And if we multiply anything by the number 1, we just get itself out. So multiplying a over b times d over d doesn't change the actual value of it, even though it looks different. Then c over d here, the second fraction, can be multiplied by b over b in order to get our common denominator of b times d. Now, even though we didn't quite review multiplying fractions, I do expect that you remember this. So the way to multiply fractions together is actually the easiest thing to do with them. You multiply across the numerators and you multiply across the denominators. So our first fraction here is going to become a times d over b times d. And our second fraction here, we'll do the same thing. We'll multiply c times b and d times b. I'm just going to write those in alphabetical order, so this will just look like b times c, or bc, over b times d, or bd. Now the final thing to do here, now that they have a common denominator, is to add the numerators together, and then we will keep the common denominator in our final answer. So putting these together into a single fraction, we'll have a numerator of AD plus BC, and then our common denominator will stay at the denominator, so that'll all be over B times D. Similar to adding fractions, we can of course also subtract them. This is extremely similar to adding. We still need to get a common denominator, but then after that we will just subtract the numerators and keep the common denominator. So again, to get the common denominator with these two fractions here, a over b and c over d, we can just multiply the denominators together. So the common denominator here, one of them at least, could be b times d. So in order to get that in our first fraction, again, we're going to multiply this by d over d, a fancy version of 1. This will now stay as subtraction. And then c over d, again, will be multiplied by b over b in order to attain that common denominator of d times b, or bd. Then we will figure out what these are in their individual fractions. So this first one, we will just multiply across the tops and across the bottoms. We will get AD over BD, and then subtract, and I will just write this in, again, alphabetical order. So I'll write that as B times C over B times D. Now that we have our common denominator, we will just subtract the numerators. So that will look like A times D minus B times C, and then again, that is all divided by B times D. Now, please don't go memorizing these formulas unless you really like to, but the idea of getting a common denominator should be something that's not new to you. You can also kind of use this schematic here where you will multiply across, if you circle these parts of the top and bottom in each fraction in a kind of butterfly or X fashion. You will multiply A times D, AD, B times C, BC, and then whatever operation here, minus or plus, stays, and then your new denominator will be the product of the individual denominators. This also works with addition, except you have a plus in the numerator in the final answer instead. The third operation we can do with fractions is multiplying them. To multiply fractions, which we've already kind of talked about, it is the easiest thing to do. You just multiply across their numerators and you multiply across their denominators. And your new fraction will just be the product of the individual numerators over the individual denominators. So this will just turn out to be a times c over b times d. Sometimes you can then simplify this further. We will talk about that later. The last operation we can perform on fractions is dividing them. Dividing fractions is probably the second easiest thing to do. Again, we don't need a common denominator, but we do need to convert this into multiplication. So we're going to multiply the numerator fraction by the reciprocal or the flip of the denominator fraction. So what we do is we keep the top fraction, the a over b, the same. I'm just going to write that the way that we normally see it, a over b instead of a slash b. And then what we do is we flip the denominator. Fancy math word is reciprocal. So instead of c over d, we're going to just flip what's in top and what's in the bottom. So it'll look like d over c. And then we change this divide to multiply. Now we already know how to multiply fractions together. We just multiply across the numerators and we multiply across the denominators. And that gives us our new top and bottom in our answer. So this is just going to look like a times d over b times c. For many of us, fractions are probably a little intimidating. Most of the issues working with them come from incorrectly simplifying by canceling things out that probably shouldn't be canceled out. Please pause this video and see which of the first three equations seem correct or incorrect and why. Here's a hint. Two of them are correct and one is incorrect. If you thought the left equation was correct, nice job. We can cancel out an x from the top and bottom since 4 is multiplied by x squared, and then we are dividing by x to the first. And of course, multiplication and division undo each other, or are opposites. So we can say that x squared divided by x will just leave us with x to the first. And then this 4 is really divided by the 1 in the denominator, and so this will leave us with 4x. So this one is good. If you thought that the middle equation was correct, look again. It is tempting to cancel out the x here and here in the same way as in the first equation. But remember that multiplication, which is here, and division undo each other. But here we have a plus 8. This means that the 8 is also divided by the x. So if you cancel out this x in the bottom with one of those x's up top, then you are completely ignoring the fact that this 8 is also divided by x. So to summarize, these x's here do not cancel. If we cancel out these x's in the top and in the bottom, or make it 4x to the first instead, we are again completely missing the fact that this 8 needs to be divided by the x. So to fix this, we could divide this 8 by x in our answer. So again, this middle example is incorrect. We must be able to factor out an x from all terms up top in the numerator in order to have canceled it out with the x in the denominator. If you thought that the equation on the right was correct, great work. Here, there is an x in both terms in the numerator, 4x squared plus 8x, so we can factor it out. Then since we are multiplying everything up top by x and then dividing everything by x, we can cancel the x's. So what I mean by this is that we can factor out an x from the numerator. That is the GCF. Well, actually, I guess a 2x would be the GCF, but we only want to cancel this x in the denominator. So let's factor out an x. That will leave us with 4x plus 8. And then notice here what we have done is written this whole numerator as x times something. Now again, x times something and then divided by x, it's like that x never really happened. We can just cancel that out. And so what we are left with here is 4x plus 8. So this one is also correct. To summarize, you must be able to divide out like factors in order to cancel over the division bar in a fraction. There are really two kinds of fractions that we might see. The first one is something times something else over something times something else. In other words, a times b over a times c. In this case, we know that this a and b written together are multiplied, and in the denominator, we are also multiplying by a. So here the a's do cancel, and that can be rewritten as b over c. This is like what we saw in the example on the left. If the numerator of our fraction has more than just a single term, so maybe we have something separated by a plus or a minus, and maybe there's even more than just two terms there, we need to be able to factor out something in common in the top in order to cancel it with the bottom. So here we see that we have an A and an A in all terms in the numerator. So we can factor out that A as the greatest common factor, or at least a common factor, and write that as parentheses B plus C. In the denominator, we have A times D, and again, now that here we've written this as times a up top and then dividing by a times everything in the denominator, here we can then definitely cancel out our a's. And then we can write this as b plus c in the numerator, all divided by d. So again, everything here had an a. When that's the case, the a's can all cancel, and you're left with whatever is left over after canceling.